everyone. Welcome to today's session at TIPCO's Analytics Forum. In this session, we'll be talking about future of analytics and the trends we are seeing in market for data and digital. My name is Shikha Kashyap, and I am the CEO of healthinsights.ai. Along with me, I have two of my colleagues, Rishi Bhatnagar, CEO of Syntelli Solutions, and Kevin Peda, the Director of Data Science at Syntelli Solutions. Today's session is broken out into two parts. In the first half, we will talk about trends in data and digital. In the second half, we will talk about a use case in healthcare industry and how we utilized data science. A little about us. Syntelli Solutions has been a long-standing partner of TIPCO, and we have successfully delivered more than 60 projects using TIPCO products and platform. We have delivered projects using TIPCO API Management Mastery, delivered analytics pipelines and platforms using TIPCO Spotfire, and implemented using projects, TIPCO cloud integrations, BusinessWorks, and so on and so forth. Our offerings span from data engineering to predictive and prescriptive and advanced AI solutions. We help our customers in cloud strategy, master data management, etc. Here's a sample listing of our clients divided by vertical. At Syntelli, we believe in yin and yang of digital and data. This is the sampling of our analytics portfolio, and they range from voice of customer all the way to fraud detection, anomaly detection frameworks. In digital side, we help organizations in their digital journey, help them with cloud strategy, build applications using microservices and APIs, and have their modern data warehouses in cloud. With that, I will have Rishi to talk about how we see future of analytics and how data and digital play an important part in analytics of any organization.
Thank you, Shikha. So future of analytics in some sense is very simple. But look, I'm not here to talk about big fancy words like X analytics and X ops and composable analytics. My idea today is to talk about some very simple things that we can learn and apply every day to make analytics more adaptable for everyone in the company. My idea is that executives now want to see results out of their investment in analytics, and how do we get to that point? And that is going to be the big focus of that here in coming few years. I break this down into three key areas. One is drivers of analytics. How are they changing today? Second is what is it that we can do to make our analytics, and what are the enablers, what's going on industry-wide, which is going to impact what we do. And the last but the most important thing is operationalizing everything. So how we got here? It took us a long time to get to the analytics maturity that we have gotten to this far. We, when I say we, I mean the industry, the vendors, the providers, the service providers, the number of people that companies are hiring. We are at a point that we are fairly mature. But what do we need to do? Where do we go from here? Here's the number one thing. The components and drivers of analytics were always considered as data. Data was an organization siloed in itself. Analytics was an organization oftentimes reported into business. And then there was this digital organization, the whole transformation organization that sometimes reported to strategy organization or into marketing or into IT. And we have to somehow bring all of these three things together. What is happening is increasingly, the data will be generated by digital assets. And what we do in the digital space has to be predicated by what data do we need to generate and how will we use. So therefore, data and digital, I see them as two fundamental pillars for a more effective analytics. Build your data strategy, fully knowing what will you do with the data that gets generated, and build your digital strategy, fully knowing and understanding what data do we need to capture, what data should be generated. So think about somebody coming to your website. We used to be able to capture some information about where they're coming from, but on mobile device, you can capture a lot more information about the users from an app. The question is, what are we doing about that digital exhaust? Are we using that? Are we utilizing that in our analytics? And the idea is analytics is a result, is an outcome. So that's my suggested key takeaway. Analytics is a derived result. So think about collaborating with your digital teams and data teams a lot better and realize that we stand on the shoulders of data and digital. The next big thing is search-based NLQ. I have a quick story. This is what Yahoo used to look like in 93-94. Some of us may remember what this kind of interface, but think about it. Yahoo had all the information. This thing had all the information, but only thing you needed to know where to go. Today's dashboards are very much like this. We have a lot of data, we have a lot of information, but business people struggle to know which dashboard to go to, then which page to go to, because a dashboard could have 5-7 pages, and then which particular picture analysis to look at. Now, the difference between we as analysts and business users is that we love to spend time on data and dashboards. The business users, they come to it only occasionally. So back to Yahoo's story. Yahoo became smarter and they said, you know what? Search will make this thing so much more easier. So they added a search bar, search the web. But search was it was a side idea, so it was a side project. The focus was still about a lot of information being presented on the home page that you could go and investigate. And we all know what happened in 1998. Google came about and Google said, look, we are going to change everything. Our search is smart. We're going to put everything behind the search bar. You can start from the search bar and get to where you want to get to. Now, Google used to list a lot of search results, and then you had to click on that search result, go to that website. If you didn't like it, come back, go to another website. Now, this is how Google has changed their interface. They say people also ask, and you keep clicking on it, and you get the results. So you never have to leave the Google interface, and you keep getting the information right there. What's our key takeaway? Complement your dashboard solution with augmented BI solutions. Look, your dashboards will always be there. I know that ThoughtSpot says dashboards are dead. Personally, I don't believe that. I really believe that dashboards are meant for analysts who love to spend time on data. But there are products like Queries.ai, which complement your dashboard, make it easier for people to go in and consume the data. So that's our key takeaway. Complement your dashboards. Think about the last mile, how we can get the insights to everyone in the company. Next is collaborative and augmented BI. There's increasing conversation around collaborations. Tom Davenport recently wrote an article on artisanal versus collaborative BI. And I totally see his point. There's how do we collaborate today? You have dashboards, you take a screenshot, you send the dashboard, you take a screenshot, send. I've known people taking picture on a mobile device and sending. We need to think of the future will be bottoms up collaboration, enabled for all users. It will not, our analytics that we build will not be handcrafted, slow and expensive, but it'll be you build it once, automate the hell out of it, and enable it for all users. Our KPI is going to be measure how not just how accurate the model is, but what is the ROI to the organization. That shift has to happen in the mind of every single analyst. So what's our key takeaway? If his stakeholders don't see what we build, if they don't use what we build, we would have failed in our mission. And again, when I say we, not just you and I as analysts, but we as also the industry, the vendors, the service providers, and everyone. Last but most important things, AI and ML ops. This will take so much more prominence as there is pressure on seeing results of the investment in data and analytics. So what is ML ops? You can read up on that, but in very simple terms, data plus models plus DevOps will give you ML ops. There's quite a bit of parallel between DevOps and MLOps, but still there are significant differences between the two. But adopting a standardized framework and using that is very critical for our success. And that's our key takeaway from this slide. If we do all of this thing to simplify, this is where analytics need to get to. Make it really, really, really simple for everyone to use. At least in the long term, we all need to get there. Back to you, Shika.
Thank you, Rishi. That was great. Now we are going to jump into the case study in surgery insights and block utilization prediction. A little about us. With the growing demand of healthcare industry for data and analytics, we launched a separate division in Syntelli as healthinsights.ai last year in December 2020. We provide solutions and platforms for providers, payers, and other care organizations. We have customer base of around 20 buying entities and growing, which includes the hospitals, health systems, ACO, physician groups, etc. Our solutions are built on TIBCO products and are hosted in Microsoft Azure cloud environment. I should mention we are also gold partners with Microsoft. Within a hospital, the OR department is one of the most critical resources which has the largest cost and revenue because of the aging population, and then with the backlog with COVID, the demand for surgical services has a sharp increasing trend. Therefore, hospitals must provide high quality care more effectively with limited resources by developing efficient OR schedules. Surgery Insights is the ideal solutions for surgery departments and freestanding surgery centers to understand and improve efficiencies. Our analytics portfolio monitors on-time starts, scheduling accuracy, room and block utilization, and provides actionable insights into surgeon performance. Recaptured time results in increased capacity, reduced backlogs, and a demonstrable return on investments. Most of the EMRs provide very basic surgery room usage report. At healthinsights.ai, we combine data from various sources, including EMR and financial systems, to provide the holistic view to improve efficiency in operating rooms. Couple of KPIs that are tracked by ORs are around block utilizations, the first case delay, inefficient scheduling practices, etc. St. Francis is a customer success story for us who has implemented Surgery Insights. It's a hospital with 32 operating rooms, and they see around 20,000 patients per year in their surgery. With Surgery Insights, they have seen 25% improvement in first case starts and 20% increase in their surgery block utilization, which has added up to 450,000 estimated value of recaptured surgery time. This is incredible for any hospital, a lot of dollar savings out there. We talked about block utilization quite a bit. And what is block utilization? This is one of the most important KPI that is measured in surgery department. Operating rooms are reserved in a block of half a day or 4 hours by the surgeon and the surgical team. And as we all know, surgery rooms are the most expensive real estate as well as the minute in any healthcare setting. Block utilization optimization is one way to measure how efficiently we are using every minute of the OR. Surgical interventions are responsible for 52% of all admissions in the hospitals and account for more than 40% of total expenditures of a hospital. If a surgeon does not fill up their blocks with the cases, then the operating room loses the revenue. To retain the block time, an overall 80% of utilization of allotted block time must be achieved. And there are certain standards that every OR follows. And if a utilization, let's say, falls below 80% in 1 month, the physician will be notified and then corrective actions are taken. Another problem with the block utilization is if the full surgery room is blocked 100%, then there is no capacity for emergency cases. So we need to build up the time for open time. Other factors include cancellation. Surgeons may be going on vacation, so they should be releasing their blocks with proper time within the proper time period. Scheduling, in short, in OR department is very, very complex, and every minute counts. So there we used some data science magic and help the hospitals how can they predict the block utilization and improve the scheduling accuracy. They can also detect the outliers within there. And this is one of the dashboards with the anonymized data for one of our customers. With that, I'm going to pass it on to Kevin to talk about the data science magic that he did with this particular customer.
Thank you, Shika. As you mentioned, block utilization is one of the most important metrics to understand in the operating room to understand efficiency. So today I'll be presenting the work we did for block utilization prediction. Block utilization seemed like the perfect project to implement, considering the vast amount of historical data that we had, a clear objective that we're solving for, and the impact a model like this can have on a hospital is insurmountable. So it's interesting as a consultant working for Syntelli Solutions and Health Insights because of the variety of projects that we get to work on and the variety of industries that we work in, including manufacturing, digital marketing, and for this use case, healthcare. So with all projects that we conduct at Syntelli and Health Insights, we follow a framework or methodology, if you will, to help us from start to finish and understand the steps that we need to complete to have a pretty good solution. So for this portion, I'll present the methodology that we use and tie that into how we did the block utilization modeling project. So the methodology for data science that we use at Health Insights and Syntelli Solutions is called CRISP-DM. CRISP-DM stands for Cross Industry Standard Process for Data Mining. And it's this set of 6 steps for you to follow to complete a project. CRISP-DM was invented back in 1996, but it became well more adopted in 2008 by a group of IBM engineers who were looking for a set of steps to help them solve their problems and do their work. It starts with the business understanding, and you can follow the arrows all the way to the deployment phase when you deploy your project or you finish your project. From here, you can see some of the arrows are bidirectional, meaning that when you get to one step, you may not have all the information that you need to finish that step. So you sometimes need to go back to the previous step to gain a better understanding to help you with the current step that you're on. So this is the methodology that we follow with all of our projects, and in particular, block utilization. So beginning with the business understanding part of CRISP-DM, our goal here is to understand how the business operates and more precisely how the problem that we're trying to solve actually works behind the scenes. We also want to establish what success looks like in this step. Here we're taking the business problem and turning it into a well-posed problem statement for our data scientists to solve. Here the problem statement is to use the historical surgery data and case data and machine learning to better predict block utilization. Now with each problem, there are caveats that you need to consider when creating your solution. 2 of the caveats that we have for this project are that the future block predictions sometimes need to be predicted 90 days from the current day. And also the block utilization predictions need to be created every night. So as blocks are created and cases are scheduled, the predictions need to be created so that people can start filling those blocks. Next in the step is the data understanding phase. The goal here is to get a better understanding of where and how the data is collected. Here we can start to understand how easy it will be to combine the data together or how hard it will be. For block utilization, we identified the necessary surgeon, patient, and scheduling data to create a single surgery case record. Now we get to start to sift through the year's worth of historical surgical case data to understand what each column means and how it ties back to the business. This helps us understand if we can use that column in our model and how we can use that column of data in our model. When we're looking at each of these columns, we're finding the trends, the counts, and distributions of each. This helps us understand where we can find missing data or understand distributions of some of the columns of data to know if we need to transform that numerical column for a data science model or not. After the data understanding phase is the data preparation phase, and this takes the longest in the data science process. Usually you'll spend about 70 to 80% of your time just preparing your data. This is where you're combining all of your disparate data sources together to create one single data file to feed into your machine learning model. Here we set out to create for each row in our data set is a surgical case where each column is an attribute about the surgeon, the patient, or the schedule. Now, with the columns that were given to us explicitly, that can only get us so far with a machine learning model. Sometimes what we seek out to do is derive new features from the features that are already given to us. And this is called feature engineering. Many times when we engineer our own features off the columns or features that are given to us explicitly, we can create quite a lift of the machine learning models that we build from doing feature engineering. Now we'll move on from the data preparation phase to the best and most fun phase of them all, is the modeling phase. For this project, we leveraged Python. At Syntelli and Health Insights, we go back and forth between using Python and R, but here we use Python, and we built 2 random forest regression models. While digging into the data and the modeling phase, we found that there was a difference between surgeries and procedures that were done 2 or less times, between surgeries and procedures that were done 3 or more times. So what we decided to do was create a model for each, one for surgeries and procedures that were done 2 or less, and one for procedures and surgeries that were done 3 or more times. We used regression here because the output is not binary. It's a continuous number that we're trying to solve for. Now, with our data prepared, we create training and test data sets to feed into our machine learning models. And this is to help prevent against overfitting models or even underfitting our models. We used an 80-20 split to do this. While doing this, we also tuned the hyperparameters within the random forest model to achieve the best model that we could. With the evaluation phase, it kind of goes hand in hand with the modeling phase. Here we're choosing a set of statistical measurements and sometimes business measurements to help us determine what our MVP model is. Since it's regression, we used R squared, and to help tie into the business, we used the mean absolute error. Both of these together helped us narrow down into what we are using as our best and final model. After we get our best and final model, we can start looking at the most important variables that are driving the results from our model. So we can look at the important variables, what their statistics are on each, and derive insights from those variables. After we have our MVP model, now it's time for deployment. As a data scientist, you never want to just create a model, use it once, and then put it back on the shelf. You always want to continuously use your data science model to help drive your business insights. So for deployment on this project, we hosted our Python code on Azure Databricks to schedule the building and scoring of the model. When the model is scored, the predictions are uploaded to a SQL server that's hosted on Azure, and the predictions and the underlying supporting data is sent to Spotfire for visualization and consumption of that data. And from there, those blocks can be filled with the results from this data science model. So now we'll take a look at some of the results from the model that we built. Like I said, we created 2 models, one for surgeries that happen 2 or less times and surgeries that happen 3 or more times. On the left, you can see the R-squareds for both of those models and the mean absolute errors. The models turned out pretty well, with the model that predicted procedures to surgeries that happen 2 or less times wasn't as good as the other model. And you can see that from the R-squareds and the mean absolute errors. One of the key takeaways that I want you to understand about the mean absolute error here is its tie back to the business. What this essentially means is the number of minutes that you will either overpredict or underpredict each case will take towards that block. And on the right, from both models, you can see some of the factors that are driving the results from the model. Some of the top features in the model for 2 or less procedures are the add-on rate, so how often are they adding on procedures into those blocks, cancellation rate, so how often are they canceling the procedures in those blocks, and then some other factors, including the number of procedures the surgeon did during that day in that block, and the type of procedures that are being done. One of the most interesting things about the other model for surgeries and procedures that were done 3 or more times is that we were able to use the historical case durations to help us predict what the future case durations would be so that we could get a more accurate block utilization schedule. So these are some of the results from the model that we got and are being outputted back to Spotfire. Now we'll take a look at a high-level architectural diagram that we use for our data pipelines. At Syntelli and Health Insights, we can ingest data from a number of different sources, whether it be a flat file that's hosted on an FTP server, streaming data in from your website, or just consuming data from your API. From those layers, that data can be stored in any number of data stores, whether it be a SQL Server, blob storage on Azure, or just hosted through Kafka in an event bus. That data is then persisted to our analytics and machine learning layer, where we use a number of different tools ranging from Azure Databricks, Python, or R, which can be hosted on Azure Databricks. And just depending on the project requirements will dictate which one of these technologies or tools that we use. From that layer, from the machine learning and analytics layer, the results can be shipped off to the consumption layer, usually through TIBCO Spotfire. Now people can start consuming the results from those models and driving insights and taking action on those insights to help drive the business. And that, in a nutshell, is the block utilization prediction model that we built for Health Insights. Thank you.
Thank you, Kevin. And with that, we'll end this session. These are our contact emails, and we will love to get in touch with you. Please do follow us on LinkedIn at healthinsights.ai and syntellisolutions.com.